Hey guys, welcome to another stream. Today it's day 59 of intelligence maxing. So, actually, before I even start this, I might have to go use the bathroom. So, I'll be back in a sec. I just had this sudden urge to take a shit because I just had some coffee. I'll be back in a sec. I'll be back in a sec. Also, I might change the stream to maybe Anki. And then also, let's introduction. Wait, let me see who these guys are. James H. Stock. Okay, I'll be back for a sec.
哎，你是不是拿了那个地下室的那个是凳子拿走了？折叠凳？哎，没有啊。后来那盒没拿呀，你看地下后边的凳子弄哪去了？ 晚上什么时间吃？
我什么时间？
要做吗？啊？
什么时间都能吃。
给你做吗？饿了现在？
现在不饿。
那就再等会儿1个小时。
Okay, that sounds good.
石锅饭啊。
Okay.
海鲜的，给你煎点鱼。
Yeah. Okay.
学习呢？
Okay, so back, and the reason I looked up this, who are the authors of Introduction to Econometrics, and what did they do? Okay, so I think these two are both economists. They're professors of economics at Harvard or Princeton. One of them is the guy I just searched up, James H. Stock. He is a professor of economics at Harvard University. I believe the other one, I don't remember his name, and I just looked at it like 2 minutes ago, but he's a professor of economics at Princeton. Likes to research macroeconomic, economic policy, and climate economics. Has a MS in statistics and PhD in economics from UC Berkeley. Mark W. Watson, Princeton professor in economics, seems to be big in the econometrics space. Has PhD in economics from UC San Diego. Okay, so that's kind of the starting point here. We have Mark Watson. Okay. We have two kind of world-renowned professors, and this is the Mark Watson guy. Oh, no, that doesn't look like economics. Okay, I think this guy's the guy, yeah. I wonder what he's, oh wow, yeah. Macroeconomic forecasting using diffusion indexes. Wow, that sounds complicated. Okay, that's interesting. So he has some interesting papers on a lot of big statistics stuff, and possibly some also economic theory and economic analysis. But I think in today's stream, what I want to do is maybe read through the first few chapters of the book. So there's chapter 1, which talks about the economic questions and data that is used to answer these economic questions. Then also goes into some details about random variables, probability distributions, review of probability, and then also review of statistics. Then goes deeper into linear regression with one regressor, so that means one variable. I think then what I might do is just start. So let's create a deck, call this Introduction to Econometrics, Chapter 1, Economic Questions and Data. Chap 1, Economic Questions and Data. Maybe also add some docs here, actually. That was my resume. Introduction to econometrics. All right. Oh man. Introduction to econometrics. Okay. So I read through maybe the first few pages of this chapter. They introduced 4 different questions that econometrics might try to solve. First one was related to testing the idea that does class size actually impact the ability to learn? And second was I'm blanking on this one. I'll skip to the third. Third was does healthcare spending or increase healthcare spending lead to better health in certain economies? And I think fourth is how do you predict GDP? I'm trying to think. So if I backtrack, the first question had to do something with think multivariable regression. Second also had to do something with multivariable regression. Could it be how smokers, let's see. Oh, is there racial discrimination in the market for home loans? Okay, so chapter 1, questions and data. So ask 4 key questions. Does improving class size help elementary school education? Are home loans racially discriminatory? Is there discrimination in home loan approval? Does healthcare spending improve health outcomes? And then also, I think finally, is what is next quarter's GDP? So there's a bit of a financial time series aspect to that. Okay, so it seems like these authors are a big proponent of answering things empirically. That's just a fancy way of saying using data. Empirically. Big fancy way of saying using data. That is by analyze data. Because we use data to answer quantitative questions, our answers always have some uncertainty. Okay. Okay, so it seems like now they're trying to talk about how you try to estimate causal relationships. And they give an example of if you were to touch a hot stove, then that will cause your hand to burn because the stove is hot, you touch it, that's the burn. So there's a direct cause between what your action is and then the results of that action. I guess in the broader sense, a lot of the different relationships that we might see through data could just be by random chance, or there's actually some type of direct correlation there that could cause some relationship to form. And I guess what they're saying here is that we estimate causal relationships with experiments. Let's see what that means. Okay, so I read through one of the paragraphs on the estimation of these causal effects. It seems like the authors James Stock, Mark Watson. Okay, so they kind of brought up the example of something called a randomized control experiment. Oops, spelled this wrong. Randomized controlled experiment. And this is something that's done to kind of estimate or determine if there is some type of causal relationship between two different variables. So they give a good example here of how does applying some type of fertilizer affect the yield of tomatoes. So another way of saying this is, does putting more fertilizer increase the number of tomatoes that are grown on this patch of land? And one way to test that is through something called this randomized control experiment. Let's see how they break it down. So let's kind of break this example. We have a how does using fertilizer increase the tomato yield? So the tomato yield, how many tomatoes are grown / harvested, are harvested. Okay, so does using fertilizer increase the tomato yield? And then how do we run an experiment? A randomly controlled experiment. So plant lots of plots of tomatoes. Each plot is tended identically. So I think this just means that same water, same amount of water, same amount of sunlight, I guess, etc. The only thing that changes is the amount of fertilizer between the plots is the amount of fertilizer used by the used. So 100 grams or 0 grams. Okay, and then the plots that get the fertilizer are randomly chosen that by a computer. So at the end, the different plots are harvested and different, and the so at the end, the different plots are harvested and the tomatoes. How should I say this? Tomatoes are weighed. Difference between the weights for among the plots is the effect of adding the fertilizer. Okay. So, good sample of control experiment. I guess the average yield. Average yield among the plots with fertilizer and those without is the effect of adding the fertilizer on tomato yield. Okay. I feel like, oh nice. It's controlled in the sense that they are both a control group that receives no treatment, no fertilizer, and a treatment group receives a treatment. Okay. Control plus treatment. So this random assignment eliminates the possibility of a systematic relationship between, for example, how sunny the plot is and whether it receives fertilizer, so that the only systemic difference between the treatment and control group is the treatment. Okay. Okay, so it seems like in real life, though, a lot of these experiments are very tough and difficult to implement perfectly. Theoretically, if you were to have a randomized control experiment and the only thing that differed was the actual treatment, then that's kind of like your best case scenario. I think I'm going to add some, so control group receives no treatment, treatment group receives treatment. So randomness eliminates the probability, the possibility of a systematic relationship between variable that is being tested and other hidden variables. So I think in the tomato case, how much sunlight a tomato plot receives can be a hidden variable that impacts the tomato yield. Randomness eliminates that relationship by including plots that have varying amounts of sunlight. Okay, I think maybe that could be one way to think about it. Okay, so prediction, forecasting, and causality. Although the first three questions in section 1.1 concern causal effects, the fourth, forecasting the growth rate of GDP, does not. Forecasting is a special case of what statisticians and econometricians, it's a hard word, call prediction, which is using information on some variables to make a statement about the value of another variable. Forecast is a prediction about the value of a variable in the future, like GDP growth next year. You do not need to know a causal relationship to make a good prediction. A good way to predict whether it's raining is to observe whether pedestrians are using umbrellas, but the act of using an umbrella does not cause it to rain. Ooh, it's actually good. No need to understand causes to make good prediction. When one has a small number of predictors and the data does not evolve over time, the multiple regression methods of part 2 can provide reliable predictions. Predictions can often be improved, however, if there is a large number of candidate predictors. Methods for using many predictors are covered in Chapter 14. Forecasts, that is, predictions about the future, use data on variables that evolve over time, which introduces new challenges and opportunities, as we will see in Chapter 15. Multiple regression analysis allows us to quantify historical relationships to check whether those relationships have been stable over time to make quantitative forecasts about futures. Okay. So I like what these guys say actually about predictions and forecasts. So forecast is a prediction about the value of a variable future. So like GDP growth the next year. And then let's say Mark Watson, James Stock, right, claim that you don't need to understand causal effects between variables in order to make a good prediction. So they give an example of observing whether people have umbrellas out in the streets is a good way of predicting whether it is raining or going to rain, but just having umbrellas is not a good way of, does not cause it to rain. Does not cause rain. Okay. So, okay. These guys talk about 1.3 data sources and types. So it seems like there's two different types of data: experimental and non-experimental observations of the world. All right. Would it be ethical to offer randomly selected teenagers inexpensive cigarettes to see how many they buy? So because of these financial, practical, and ethical problems, experiments in economics are relatively rare. Instead, most economics data are obtained by observing real-world behavior. I'm gonna maybe subheading 3, so you have experimental data, non-experimental, also known as observational data. Maybe some examples. So for experimental data comes from experiments designed to evaluate treatment causal effect. So 1980s Tennessee experiment funded an experiments on class size, examining class size in the 1980s. This was a really complicated experiment. Most of the time, experiments is really difficult to conduct experiments with humans. Ethical concerns. Administration funding. Okay. Administration funding. Okay, so experiment data. Observational data is a helpful alternative, but usually the data is not random, so there could be underlying relationships. Between the treatments and other factors that can make the data bias. So I guess when I say bias, what I really mean is that there is some hidden relationship between maybe our treatment, which is bringing it back to the tomato example, the yield based on the fertilizer. So the treatment itself is the amount of fertilizer used, but that could be related to okay. So there are usually other hidden variables that affect the outcome in addition to the treatment. I guess affect the outcome. So I guess this going back to the tomato example. In the tomato plot example, the amount of sunlight is one of those hidden variables that will affect the yield, that can affect the yield in addition to the amount of fertilizer used to the treatment. Okay. So I guess a high student-to-teacher ratio means that there are more students compared to teachers. Low. All right. Panel data is called longitudinal data, or data for multiple entities in which each entity is observed at 2 or more time periods. Okay, so I'm gonna kind of break this down a little bit further. Just like the authors James Stock, Mark Watson did. So within kind of your experimental and non-experimental data, you also have 3 different ways to classify data. So the big 3 are, data. This would be called data sources. And then we call this data types. So you have cross-sectional, and then time series, and then panel data. So this is data at a single time period for multiple entities. Data multiple time period, single entity, and then multiple time period, multiple entities. Okay. Describe a hypothetical ideal randomized control experiment to study the effect of 6 hours of reading on the improvement of the vocabulary with high school students. Okay. You were asked to study the causal effects of hours spent on employee training, measured in hours per worker per week. Okay. So there's some interesting conceptual concepts to review here. I think I might skip those for now, come back to them either tomorrow or a different day, so I can kind of let this information to kind of sit and marinate. But now chapter 2 goes into a review of probability. So I think this is going to be pretty important. Okay, so some interesting derivations here of variance, which is helpful. The variance of the sum of two random variables. Showing probabilities for two random variables x and y summarized by their. Okay. So it's almost 6:30. I think I'm going to try to read, maybe skim through this quick as possible, and spend some time maybe adding some flashcards. Yeah, I'll do that around 6:30, and then probably moving on, I need to work on my presentation for Eli Lilly, which I might do on my other channel, Think Fund. Yeah, okay, that sounds like a good plan. So 3 minutes, let's see if I can just read the intro here. So most aspects of the world around us have an element of randomness. The theory of probability provides mathematical tools for quantifying and describing the randomness. The sample size is sufficiently large, however, the sampling distribution of the sample average is approximately. Okay. Probability distribution of a discrete random variable is the list of all possible values of the variable, probability that each value will occur. Okay. So I think I'll end this here. There are some interesting things to note in, should say, let's do heading 2, chapter 2, probability, review of probability. So for discrete random variables where the number of outcomes for that random variable is finite and countable. Or countably infinite. It's a list of the outcomes for that variable and its associated probability. Okay, we'll be back. Okay, so maybe I'll try to add, let's say, book, introduction to econometrics, author James Stock, Mark Watson. Authors, and then do topic, chapter 1, I think it was, what was it, data questions? Okay, so economic questions and okay, so I think the first question I want to ask is, how do the authors define econometrics? So they define econometrics as the science and art of using economic theory and statistical techniques to analyze economic data. So it's both a science and art using economic theory and statistical techniques to analyze economic data. Okay. So that was kind of the big thing I wanted to get out of the way. What does empirically mean? So, yeah, these are kind of the softball answers. So, empirically is a big fancy way of saying using data when someone says they are using an empirical model, that means they are using data to back up, to build and validate the model. Okay. So what is a randomized controlled experiment? What so why is it so important? So a randomized controlled experiment is a way of estimating the causal relationship between variables. Between two variables. So maybe we can define each word. So randomized, this just means that okay, maybe we can work backwards, because actually that might make more sense. What's an experiment? I think an experiment is maybe just a process or a project to test some type of hypothesis or idea. And the controlled portion of this experiment maybe kind of describes how this experiment or process is set up. Basically, you have two different groups, the control and your treatment. The control group is the group or the participants in your process that receive some type of treatment, which is really the thing you want to test. And then that's the treatment group. The control group is the portion or people in our process that receive no treatment, nothing at all. And randomized just means that you randomly assign the treatment to the different people. So the control and the treatment groups are randomly created. Why is this so important? Well, this represents kind of the theoretically ideal way to estimate the relationships between variables, just because you have everything else is identical in your experiment except for the control and the treatment. Okay. Experiment is a process for determining to test some hypothesis / theory. So a hypothesis really is a theory. You could say, for example, a theory that if you drink milk every day, you'll grow taller. Or drinking milk every day will help you grow taller. So that's a theory. And how do you test that? You test that by running an experiment. So it's just some type of abstract way of saying you run some type of process or you test your ideas. Okay. Refers to the use of a control and treatment group. And then randomized refers to the random assignment of the control and treatment group. Okay, so this is important because these types of experiments are the theoretical, I don't know. Oops, nope. Theoretical ideal way to estimate causal relationships. So this is important because these types of experiments are the theoretically ideal way to estimate causal relationships that, by keeping everything in experiments identical and the only varying factor is the treatment being the only varying factor being the treatment. Okay, I think the last one I want to make here is describe the tomato plot example for a random James and Mark gave to describe a randomized controlled experiment. Okay. So to set the scene, I guess to understand problem, the question that was being asked here is whether using fertilizer, specifically 100 grams, would increase the yield of tomatoes. So this is how many tomatoes were harvested. Does using fertilizer, specifically 100 grams, increase the yield of tomatoes? Okay. To estimate this answer, we can conduct a randomized controlled experiment. Okay, so how would that work? So let's say split the land into different plots, and then randomly assign each plot to a control or treatment group. Give the fertilizer to the treatment make sure that each plot is identical. Is tended identically. Tended identically. Receive the same amount of water. Same amount of soil, etc. So yeah, I feel like sunlight might be hard. So at the end, calculate the average yield for the treatment versus control group. The difference is the effect of the fertilizer on the yield of the tomatoes. There you go. Difference is the effect of the fertilizer on the yield of the tomatoes. Okay. So if we were to describe the tomato plot example that James and Mark gave to describe a randomized controlled experiment. Yeah, the question that was being asked here is, does using fertilizer, specifically 100 grams, increase the yield of tomatoes? Basically asking how many tomatoes were harvested. To estimate this answer, we can conduct a randomized controlled experiment. So basically how it worked was we split the land into different plots and then randomly assign each plot to a control or treatment group. That just means that we give the fertilizer to the treatment group and do nothing for the control group. We also want to make sure that each plot is tended identically, so they receive the same amount of water, same amount of soil, same amount of sunlight. That means the only thing that is different between the different groups is the fertilizer. The amount of fertilizer. And at the end, we calculate the average yield for the treatment versus control group. The difference is the effect of the fertilizer on the yield of tomatoes. All right. So that kind of quantifies the effect of quantifying the effect of adding fertilizer okay, so that's good. I'm gonna probably save this here. I'm gonna end the stream for now. Probably going to do some work for my Eli Lilly stuff. So thanks for tuning in and catch you guys in the next one. Peace.